on Europe Accelerates Towards 6G, focusing on the ICT 52 projects, but trying to look at it not just from a project by project basis, but really trying to get at some of the key questions behind this whole beyond 5G, 6G ecosystem. So maybe I can welcome everyone and start by just quickly showing the agenda to make sure everyone's on page. So I will just say a few words, literally a few words, and then I will hand over to Bernard from the European Commission, who will give a little bit of an introduction or context. And then we have two sessions. And the two sessions are the first session is focusing on the 6G vision. And the second one is more about technical enablers and challenges. And how we were trying to do this is we were trying to do it that each of these ICT 52 projects will have one slide and 5 minutes to introduce their ideas on this subject. And then we will have a panel discussion. If you wish to make comments or questions, please do not do it verbally or online. Please use the chat. So let's just go over the rules one more time for people who joined. Please stay muted if you are not talking. We're expecting 450 to 500 people attending this meeting. If we all start talking, it will be chaos. So please double check now that you are muted. And only unmute if you are presenting or talking. If you have comments or if you have questions, please use the chat window. We'll be looking at that, trying to pick up any questions from the audience. For those who are presenting, I'm afraid I need to be quite strict on that 5 minutes. We really have a very limited amount of time. We have, I believe, 9 projects. If I let one overrun, then we will have no time for questions at the end of the panel. And that part, I think, is in many ways perhaps the most interesting for a lot of the participants and people viewing this. So we need to have that time. So I will be quite strict saying, right, that's it, please stop. Okay, those are the rules. Welcome again. I would now like to hand over to Bernard, who will now present the introduction from the European Commission. Bernard, the floor is yours.
Thank you very much, Colin, and good morning, everyone. You can hear me, it's okay?
Perfect.
So I will try to share my slides. I hope it's going to work. Does it work?
Yes, that's fine, sir. Perhaps you could put it, yeah, perfect.
So I go full screen mode. So, okay. So good morning, everyone, or good afternoon, depending on where you are. And just a few words on where I am. I belong to DG Connect, which is in the European Commission, the department which is looking into the digital policy for Europe. And in my division, where I belong to, Future Connectivity Systems, we have 2 basic activities. One which is support to research and innovation through funded programs, either very early in the research process or more in the towards deployment. And the other part of our activities is trying to put in place the right framework conditions in Europe for a deployment of network. That means things which are more of a regulatory nature, such as spectrum standards or the right regulatory incentives for Europe to deploy 5G type of technologies. So if I look at the funded research part of our activities, just one slide to tell you where we are coming from. We're coming from the so-called 5G PPP, public-private partnership, that we started with financial support of 700 million euro on the public side. Early in 2013, we had several phases where we moved from, let's say, early research towards deployment. But at the very end of this program, we had anticipated to have a part of the activities related to how we look into the future and what comes next. That means what comes after 5G, taking into account, as you all know, that the cycle for from one generation to the other is about 8 to 10 years. So we thought at the end of 2019, 2020 could be good to look with the stakeholders what they see coming beyond 5G. And this is, in our view, a very timely move. If you look at what's happening in the other regions of the world, we have very strong initiatives now, which are starting from the let's say, from the perspective of our main competitors. Be it on the US, where they have already started in the Secure 5G and Beyond Act to to identify Beyond 5G as a domain to promote research activities through the NSF, for instance, but it's not only the NSF. We see a DoD funded program for 5G and beyond test beds, and more recently the so-called Next G initiative that was discussed in the United States. And the same thing you can see from Japan, Korea, China, where there are a sizable amount of money which are now being put on the table to look into the future with, in some cases, in particular for Japan and Korea, specific 6G roadmaps which have been put on the table and identified as kind of a work program. China also is very active. In Europe, we had the first, let's say, flagship 6G event launched already early in 2019 by our Finnish colleagues with the so-called 6G flagships. And on our side, at European level, we are now in discussion to put in place the so-called 6G Smart Network and Services joint undertaking, which is a partnership, let's say, kind of extension of the 5G public-private partnership, which is the proposal that we have on the table to inject into this domain 900 million euro over the next 6 to 7 years. So very quickly, what are the, let's say, the status of the discussion we have with the stakeholders at this moment in time on the 6G story? We have started to discuss with the European research people, industry and academics, what could be the key components of a future beyond 5G type of initiative. And here is a kind of summary of the main topics that we can see emerging. Of course, this will be further discussed or further itemized through the project that will present their roadmap and their activities in the next few minutes. But what we can see as framing elements are basically on the top right. You can see the so-called vertical use cases beyond 5G, which means that the very strong convergence of networks with vertical digital use cases that have been pioneered with 5G, that we see appearing in 5G, we believe this will still be a very strong, let's say, driver towards 6G by looking into applications in the vertical domains that will probably necessitate KPIs beyond what 5G has been designed for. That means KPIs beyond 20 gigabit per second for the carrier rates, or lower than 1 millisecond for the latency, or more than the 5.9 reliability figure. So we see this kind of very, very demanding use case already appearing in specific contexts like factories or automotive. So that's probably one of the very strong drivers from the application side. On the left-hand side, we see also new classes of applications. Maybe the most innovative one is the so-called Internet of Sense that realize a kind of coming together between the communication capabilities of some frequency bands like terahertz combined with their sensing capabilities, which allow at the same time to have communication and sensing merged or mixed to provide innovative applications. I believe some projects are working on this at this moment in time, but also more, I wouldn't say classical, because they are not widely spread at this moment in time, but immersive type of application like extended reality, holographic communication, or digital twins are applications which require massive amount of digitization of the, let's say, surrounding environments with huge volumes of pixels to have a good rendering of the volumes or of the images, which are potentially bringing the capacity requirements in the terahertz domain, which has also some impact on the architecture of the network, especially on the edge side. And of course, massive M2M, there are some prospects that look at more than 500 billion of machines communicating with each other. So almost 100 times more than humans on the planet. So that is something which is also pushing the envelope towards a new generation of networks. Now, if you look at the very bottom of this slide, where you have these two elements called ultra-low energy EMF and sustainable development, these are things that we consider from the Commission perspective of new things in the sense that we didn't put too much emphasis in the 5GPP on this type of issues, but we see these issues which are rooted in societal type of concerns becoming much more prominent for the future. Most of the time they correspond to so-called non-functional properties. So that's not something that you can see or experience from the point of view of the application. That means the energy consumption of your network is not something that has an immediate visible impact on the application you are running. But these are things which we believe are very important. For instance, aspects such as ultra low energy on the network side or EMF control, which we see as a concern coming more and more from the population, citizens, are, we believe, aspects which have to be taken into account. And from the energy side, it's not only the optimization of the energy of the network platform that we are interested in, it's also how the network platform can be used or can contribute to lowering the carbon footprint of the vertical use case, which is running on top of it. If you take connected cars, for instance, it's clear that connected mobility may help cars to consume less fuel or to be more effective in the way they are running their journey when you have to go from point A to a point B. And there are also, of course, other sustainable development goals objectives, such as affordability of the technology, accessibility to the infrastructure, openness, and dedicated, very important applications such as agriculture, for instance, which we are interested in looking into from a more systematic aspect at the level of the research and development for the future. And in the middle, this is basically an important concern from the stakeholders, which is to minimize the, let's say, the management cost and to optimize the management performance of the overall infrastructure, which is related to the emergence of artificial intelligence that can be potentially integrated at each and every layer of the value chain, be it from the physical layer or up to the service layer. You can use potentially artificial intelligence to optimize the network capabilities. This being combined with something which is of high interest for the policymakers these days to realize ultra-high security networks, again with potentially new technologies which are coming under scrutiny, such as blockchain or quantum communication. So that's a kind of very rough sketch of what could be the technological elements of beyond 5G type of initiative. And in that context, we have been working with the stakeholders. So first, to have this first so-called bridging phase, which consists of one flagship 6G project plus 8 6G exploratory projects, which are being launched now under the 5GPP at the end of the 5GPP. And these are the 9 projects that will expose their views and their 6G vision today in this webinar. But this is a bridging phase which will lead us to the implementation of what I mentioned before, the so-called 6G partnership, smart network and services. And as you can see, this partnership has 2 legs, one which is promoting the deployment of 5G, and the other one is to really research and look into future technologies for future platforms. 6G first try to have a kind of clean vision of what it could be, and then look into the technologies that can underpin this vision. And as you can see, this smart network and services proposal, you can find the URL here, which is the roadmap proposal by the industrial stakeholders. The industrial stakeholders, they are belonging to these 5 associations that you see at the bottom of the slide, and this reflects the so-called value chain approach that we want to use to look into these future platforms systems. because we believe we have to take our strongholds in connectivity in Europe to try to expand that to also seize opportunities across the full value chain. That means on the device side, taking into account that there will be lots of opportunities of new generation of devices with IoT and massive amount of connected device that will go much beyond smartphones. And also on the service sides with, let's say, edge computing or edge cloud capabilities, where we believe there are potentially opportunities for Europe, including the component aspect. So again, we take a full value chain approach from the component to the service delivery, trying to maximize or optimize the strongholds that Europe has in connectivity to try to reconstruct capabilities in the other domain where we are less strong. So this is a kind of roadmap that we could potentially imagine for these future systems. As you can see, there is a kind of agreement. I wouldn't say it's a strong agreement, but more or less people tend to agree that deployment for these next generation platforms will be around 2030, whilst the standardization should start sometimes around 2025, which gives us for almost 5 years time to run very strong research and to be very well prepared when the standardization bodies open the race for standardization, the right technologies. What may be of interest and what we believe the projects we are going to discuss today could potentially have an influence is on the overall vision. As you may know, the ITU, which published the 5G vision around 2012 in a document called the Recommendation M2083. This was a very popular recommendation where you had the 5G triangle, EMBB, MMC, and URLC that you probably know. ITU intends to have a similar document early 2023, and next year they will already publish in principle a kind of a catalog of technological trends and let's say identify the main technological trends framing the future. So this is an important exercise where potentially the projects could contribute. And ITU this year already will organize 2 events in June and in October to already collect this type of requirements and future technological trends. So on our side, when it comes to putting in place the partnership, we have in mind the adoption of the legal text, which is, if you want, the birth certificate of the partnership that we are proposing. We hope to have this agreement at the level of the Council around September this year in such a way that we could start having a work program operational by the end of this year and start launching the first goals before the end of this year. So this is the program, the tentative program we are working against at this moment in time. And maybe if you want to have a few more information, you can look at the roadmap proposal from the industry, which was published already in June last year. You can see also the Horizon Europe partnership. That means all the partnerships that the Commission is proposing for the next period of time, with a focus on the smart network and services 6G. And also, you might be interested in our EU CNC event, which is organized in combination with the colleagues on Finland, with the 6G flagship of Finland, 11th of June, where we will have a large conference dedicated to 6G developments and technologies in Europe. So that could be of interest for this community. So with these few words, I hope it was clear, and I hand over to Colin, and I wish you a very nice webinar.
Super. Thank you very much, Bernard. I think that, at least I thought, was very clear. And apart from someone asking if they can have your presentations, no questions. So that's excellent. Then I think looking at the time, we need to move on to the main body of the webinar today. So maybe I can take the sharing rights back, and
well, sorry,
I'll just steal it. Sorry, it's the sort of person I am. So let's see how well this works. So what we have is we have the 9, I believe, projects from ICT 52, and they were asked, please, to give one slide on their 6G vision. And clearly, if you look at the moment, none of us know what 6G will be. At the moment, as we so often do in the telecoms world, we create a name, and then later we'll decide what it means. And 6G is certainly that, where 6G, we have some ideas of perhaps the core technology, but it's still very much in the formative stage. And now is the time for fundamental research, for thinking of ideas, thinking of what 6G might be. And that's why I hope this will be so interesting, trying to get that view from these key first round of European 6G projects. What's their vision for 6G? What will 6G bring? What will it give? Okay, with no further ado, then let us move on to the first of the projects, 6G Brains. And please, your 5 minutes starts now.
Yeah, and can you hear me?
Yes.
Good. Okay, 6G Brains project will deliver a lower comprehensive cross-layer deep reinforcement learning framework to driven the resource allocation solution to support massive connections over the D2D clusters. And also this kind of clusters will be supported by the high dynamic cell-free network, and with several links, including the sub-6G, millimeter wave, terahertz, and also open the optical wireless communications. Besides that, and there will be proposed a 3D simultaneously location and mapping technology to support the high accuracy location for the IoT devices. So the technology and the vision of the 6G Brain, first we will consider the enhanced new spectrum link, such as OWC and also terahertz. So they will provide the comprehensive channel model based on the real measurement at Bosch workshops to support the multi-band channel models, including the OWC and also terahertz. And second, the 6G Brain will be provide the AI-driven, the D2D cell-free network architecture to support the moving and the dynamic and also higher density channel environment inside the like indoor warehouse. And also third will be support the end-to-end direction network slicing with a guaranteed different performance KPI towards 6G. And fourth is the data fusion for the digital twin, suppose the digital warehouse, and also the virtual data based on the virtual environment. So the proposed solution will be validated by a proof of concept trial at a Bosch warehouse. So the primary and also secondary application of the proposed in the proposal will be for high broadband spectrum, such as OWC and the terahertz, also will be evaluated at Bosch safe content smart factory. So besides that, this technology not only deployed in the indoor environment at Bosch, also will be support the widely various vertical sectors such as Industry 4.0, auto, intelligent transportation, e-health, and others. And regards the vision, and also Bosch has set out for this technology, we will support their flexible production line. So their production environment is fluent. So only the walls and the ceilings are fixed. Other components and the machinery can be moved and reconfigured based on different production requirements. So this will be including the industry machines, devices, and the vehicles will be made mobile by the 6G and also beyond 5G technology, and made intelligent by the edge and also cloud-based analytic, and enabling the factory owner to change their production lines according to the demand in a short period of time. So this environment will be reconfigured at a different time slot and based on requirement. So the massive connected IoT solution will be envisioned to be one of the most promotion driven for many of these emerging use cases. So including such as industry automation as means to deploy the reconfigurable and the production systems, and which can be turned up and down according to the real-time requirements. So this
30
is
seconds, please.
Yeah, this is how the 6G vision regards the 6G. Okay, I'm finished.
Super, perfect timing. Well done. So very interesting. Please, can you turn your, thank you. So very interesting, thank you very much, especially the use of visible light. I think that's a key area which is very interesting going forward. I have not seen any other questions in the chat. I was asked, and forgive me, I missed the message. I should have announced at the beginning of the session that this session will be recorded. So there will be a recording of this available for people after the session so that others who are interested can actually see this overall European project view of where 6G is going. Okay, let us then move on. And the next project to present is AI at the Edge. Please, the floor is yours. The 5 minutes will start now.
Hello, good morning, good afternoon, and good evening to everybody. My name is Roberto Riggio. I am the technical manager of AI at the Edge. Let me put our vision in a nutshell. Our vision is for a future where artificial intelligence will be on the evolutionary path of every object and service that we humans will interact with. There is no need to provide a lot of evidence for this. We see it already on the automotive, on Industry 4.0, in broadcasting, in entertainment. There are plenty of examples that prove this. Our vision is that 6G, and in particular telecom operators, sit at a crossroad in enabling this vision, in providing a platform, a convergent, connect, and compute platform that can enable this vision of AI-enabled application and services. In this context, our approach is around 3 main ideas, which is to leverage the concept of reusable, secure, and trustworthy AI for network automation in a stakeholder that is composed by many stakeholders. So now, why reusable? Reusable, it is because it is not acceptable that future 6G system will have AI silos. It's not acceptable that AI advances in one field that cannot percolate in other field of the network. So one of the approach of the project is to build reusable machine learning pipelines that can be decomposed and reassembled according to the need of the specific vertical. And this will be used both to run application as well as to optimize the network. So it will be possible, for example, to have ingestion, filtering, preprocessing, model building, and deployment as a sort of Lego pieces that can be recombined dynamically and inflexibly across a very distributed and pervasive edge compute fabric that spans from the user to the centralized cloud. It must be secure because we are putting AI into the inner machinery of the 6G network. We are putting AI to optimize the network itself, optimize how resources are allocated. And we know very well how artificial intelligence and machine learning can suffer from certain attack. If we think about the image recognition area, we know very well that inserting certain patterns in the images can trick the machine learning algorithm. We do not want that traffic injected into the network could trick the machine learning algorithm in taking wrong resource allocation decision. And finally, we want this to be trustworthy. because if these reusable pipelines are used by different verticals, we want these different verticals to be sure that they can trust that their data is kept siloed and protected from each other. The goal of the project is to achieve an EU-wide impact on industry-relevant aspects of AI for networks and networks for AI for beyond 5G systems. So when I say AI for networks, I'm referring to the application of artificial intelligence solution to manage, to run, to optimize what will be a future beyond 5G system. The argument here is that the networks are becoming more and more complex. The number of nodes we can optimize is increasing, and we need more powerful solution to do so. The part of networks for AI is instead referring to the realization of a unified execution environment, spanning from end-user terminals to centralized cloud, going through central office, near and far edge computing, in such a way that this execution environment is seamless to the application developer, and it's basically allowing the application developer to perceive all the resources as local, even if they are remote, far away, or if they are under volatile condition. And this in time can basically allow to converge connectivity and computing for better automation, increased performance, decreased time to market of new feature, and also greener operation. Because by providing this seamless fabric, it is possible to reschedule workloads and activities, for example, in area of the network where the production of electricity is done using renewable fuel, or maybe it's possible to shut down portions of the network. The project will target 4 use cases: one on automotive for validating cooperative perception, one on the Industry 4.0 for security, one for edge and drones for monitoring on linear infrastructure, and the final one will be on content curation for in-flight media service. And that will be all.
Okay. Yeah, thank you. That was also very good, sir. You covered an awful lot of ground. I noticed there was one question, which I believe would be for you, which is saying, can you name an example where the long-term instead of simultaneous reward matters such that DRL is necessary rather than supervised learning? Forgive me, that was to the previous project, so forgive me my misunderstanding. I thought when they were talking about learning and AI, but my mistake. Let's take that offline and do that by chat. Thank you very much for your presentation. Let us then move on to the next project. So we now have, I believe it's Demon is how it's called.
That's right.
The floor is yours. Please go ahead.
Thank you, Colin. So good morning, everybody. My name is Marco Fiore. I'm the project coordinator of Demon. So our project stems from the notion that 6G will ultimately be zero touch. This means that due to the increasing complexity of the network infrastructure, as well as of the services that the network will support, traditional human-in-the-loop approaches to network management will not be viable anymore. So what will happen is that in 6G networks, a wide range of algorithms will run at controllers and orchestrators across the whole infrastructure, basically self-managing the network. And we jointly name this whole set of algorithms as network intelligence. Now, this also means that the success of 6G as a whole technology will largely depend on the quality of the network intelligence that will de facto manage the network infrastructure. And we as a project identify a number of fundamental design gaps that need to be filled for a proper integration of network intelligence in mobile network architectures. So I'll give you 3 examples. First one is the fact there is a trend nowadays of considering a complex black box AI model based on deep learning as some sort of silver bullet that will solve any network management problem at hand. while in the project we take a more critical approaches, and we will perform a systematic analysis of the limits of AI models. By AI here, I mean, again, deep learning, and understand when and where these models are really necessary for solving network management problems, and where they should be instead complemented or even replaced by maybe less fancy but let's say solid and efficient solutions from statistical or analytical modeling or optimization. Second, network intelligence algorithms nowadays are often designed by borrowing tools from machine learning community and adapting them slightly to the needs of the networks. Daemon takes a different approach and believes that the design of the algorithms must account for network specifications since the start of the design process itself. Since the network environment has unique requirements in terms, as an example, of latencies of execution of the decision making, as well as limits in the computational resources that are available at different points of the networks. And this needs to be taken into account by design. Third, the network intelligence algorithms are often designed as if they had to operate in a vacuum within each controller, orchestrator, or domain, which is clearly not the case in reality, since the decisions that are taken by given network intelligence instances have a reciprocal effect on their operation. So there is a need for a global coordination of network intelligence across the whole network. Daemon tackles these gaps from two complementary perspectives. So on the one hand, we aim at rethinking the way artificial intelligence is designed for networks by combining all the possible tools we have at hand and accounting for the requirements of the network management functionalities by design. And on the other hand, we also want to help rethinking how network architectures are designed for network intelligence, basically helping and paving the road to future standardization in 6G, so that 6G mobile network architectural models natively support the operation of the network intelligence in the best way possible. And the vision of the project is exactly that. We think that those two components need to come together in order for network intelligence to be a practical approach in 6G.
Super. Thank you very much, sir. I noticed there were some questions which maybe we can, I think they're pretty much the same question, where they're asking about how the human is brought into the loop. Can you explain a bit more about human in the loop and how it is done? How do you integrate humans in the network? So.
Yes, so sure. The point is that nowadays, network management is heavily dependent on human-in-the-loop solutions. So a lot of, if not all, management decisions involve expert knowledge. And this is viable, this has been viable in the past, but nowadays the fluctuations in traffic demands and the fluctuations in the requirements of different services are becoming so rapid and so complex that relying on human intervention is going to be risky, or at least will basically lead to suboptimal decisions or slow decisions that will require operators to invest a lot in terms of over-dimensioning and over-provisioning due to the ineffectiveness of the network management. And the idea is exactly that. The idea of zero touch is exactly that. By automating the network management, we reduce substantially the intervention of humans, and we speed up the whole process of managing resources across the network. So the idea of the project is actually that of minimizing the presence and intervention of human experts in network management.
Okay, so I'm afraid I need to stop you there. There are at least 3 very good questions in the chat. If I could ask you now to try and answer Alex and Bernard and other people, because I think they are relevant and very interesting. But I'm afraid at this point, I need to move on to the next project so that we don't run out of time. Thank you very much for that presentation. So we then move on, and we now have Dedicate 6G. The floor is yours.
Yes, hello. My name is Vera Stavroulaki. I am the project coordinator of Dedicate 6G. So Dedicate 6G, the 6G vision focuses around 4 key areas. First of all, reduced energy consumption. This is often one of the primary visions associated with 6G and the vision of a green network. And while energy efficiency is already starting to take shape in 5G, it is expected that it will only be with 6G that a truly green network will come into existence. The next focus area is digital inclusion. Already at 3G or beyond 3G times, there was the motto always online, always connected. And while this is true for many more people nowadays, it does still not apply to everyone. In a sense, connectivity has become even more important in this time of the COVID-19 pandemic, enabling people to continue working remotely, having access to education, and allowing families and friends to keep in touch during lockdowns. So in that sense, it is very important to ensure that equal opportunity is offered to everyone, citizens and businesses, regardless of location, and that service continuity is supported also in areas that may be remote or difficult to reach, either due to geomorphology or due to other causes, such as natural disasters or damages imposed to the infrastructure. Enhanced security, privacy, and trust. Of course, security threats are never ending, even for more traditional networks. However, now with the openness and the pervasiveness of Internet of Things applications, human-centric applications, there are additional vulnerabilities that still make security challenging. In this context, key issues that Dedicate 6G is looking to address include secure and trusted exchange of information, as well as of the orchestration of decision-making logic between different collaborating edge devices, cloud and fog computing components, network devices, and infrastructure elements. Human in the loop. 6G is, of course, expected to offer more human in the loop services with highly personalized and substantially improved user experience. Human-centric applications such as augmented and virtual reality and immersive experiences will become central. And therefore, new functionality and software and hardware solutions are expected to emerge for sensing and detecting novel dimensions of human experience. To successfully employ such services and applications, it's also important that the network is aware not only of the quality of service of applications, but also of the perception of human users of this quality of service, so-called quality of experience. So as part of this 6G vision, Dedicate 6G aims to transform beyond 5G networks into a smart connectivity platform that is green, highly adaptive, ultra-fast, and dependable for securely supporting innovative human-centric applications. Dedicate 6G will demonstrate and validate its developed solutions in a series of proof of concept pilots, which include smart warehousing, enhanced experience, public safety, and smart highway. So this is it from my side. Thank you very much.
Thank you very much, and thank you also for staying within time. It's very much appreciated. There was one question perhaps from Dan, which I could perhaps highlight, which, if I understand correctly, is about inclusion, because you mentioned inclusion and improving inclusion, but the point he's trying to make is that when you have new technology, typically it costs more more to deploy, and more for users to adopt. You know, you see the premium charging for 5G that we had and things like that. So, and also it typically is deployed in pockets. Typically, you know, you use the new technology in things like hotspots and things like that. So how do you actually make it more assured for actually ensuring inclusion, so broadening the base of people who can use that technology?
Yeah, of course, digital inclusion depends on many factors, which are not only technological. So there are also aspects related to education and so on. Obviously, we are not touching upon those. So the main concept in Dedicat 6G is the dynamic, what we call the dynamic coverage extension. And the idea there is exactly to be able to cover also increasing demands without necessarily investing in very expensive infrastructure, but being able to utilize even mobile edge nodes or robots, cars, or drones as potentially temporary mobile access points that will be able to at least cover areas that might otherwise will be difficult to cover. So that's one aspect regarding that. And also, I was going to explain this in more detail later, but through this other key pillar that we are talking about in Dedicat, the distributed intelligence, again, we are able to migrate computation, intelligence, and so on to wherever it is needed, whenever it is needed, thus increasing much more the flexibility of the whole network infrastructure and system, with the aim of also reducing in the end the operating costs and the capital expenditures.
Okay, thank you very much. I think any further clarification is taken offline, but thank you for that initial clarification. Let us then move on. Oh, I've moved on too far, forgive me. Let me give HexaX a chance to explain their vision. The floor is yours, thank you. HexaX? Mikko? Mikko is a little bit late, sir. He's just joining. Can you talk, Mikko?
Yeah, for some reason I was kicked out of the WebEx right at the time when my turn was about to start.
Yeah, so. Do we think that's coincidence, or I don't know. Anyway, well done for coming in so quickly. The floor is yours. Please continue. Your 5 minutes have started.
Yeah, thanks, Colin. So I'm Mikko Stolo from Nokia Bell Labs Finland, and leading the HexaX EU 6G flagship project. And here you can see the HexaX vision on 6G, connecting human, physical, and digital worlds with the fabric of 6G key enablers. So we have the human world, humans are in the center, and then we are in connection with the physical world with the very efficient human-machine interfaces controlling the operation of the physical world. And then models of humans are built in the digital world, making then, for example, possible for preventive healthcare, predicting heart attacks before they happen. And so we need connectivity for both of these dimensions from humans to the physical and digital worlds. We also need connectivity between the physical and digital worlds. So we already have the digital twins models of the physical world helping the operation. Taking this to a much further extreme, massive twinning, building models of industrial complexes or cities and so on, and wider sets of the physical reality, so we can further enhance, better plan and design and operate the physical world. Also here is the aspect of this preventive maintenance, predicting problems before they occur. Then, based on the vision, based on understanding, looking at the trends, we have been looking at what are the different key values we should focus on in the project. And they are here in the center of these three worlds. So sustainability is something, a must, that we kind of everything we do has to be built on top of sustainable approach. Then, as more and more aspects of human life gets wireless, gets digital, so and we are revealing all kind of information concerning our human bodies and so on. So this the approach that we have to take from right in the beginning of the next generation is this trustworthiness. So build the approach so that this is taking a very careful look right from the beginning. Inclusion refers to that we have to make it possible that the services are available to anybody and no matter where you are. Then, based on this work, we have identified several research challenges, and Patrick in our next presentation will go deeper into those. And then I'll tell a couple of more words on these use cases. So we have been looking then why is 6C needed, what are the use cases, and group them into use case families. And this first document telling about this vision, the values, use cases, key value indicators that you can already find from our website. So on this use case family, so sustainability, for example, Earth monitoring, how in the different ways can 6G be used to enhance sustainability. Of course, 6G itself has to be sustainable, but also 6G can play a big role in other areas of society in making them more sustainable. Massive twinning, already told about that dimension. Telepresence, so how can a human or group of humans or machine or group of machines be remotely interacting with each other, interact with physical objects, no matter about the location of the physical objects, interact with some digital objects that are not yet reality anywhere, have, for example, some mixed reality co-design, or efficiently remotely interact with each other, even in a higher quality than you would be present there. Robots to cobots, how could groups of humans or or groups of machine interact with each other and have the machines working for the benefit of the humans as a team. Local trust zones, some local networks where then paying a special attention to this needs of the trustworthiness. For example, bringing the connectivity to some location with no kind of permanently based infrastructure. So that was the quick go on HexaX.
Thank you very much, Mikko. I think that was an excellent recovery from a shaky start with the tools. You covered the time. There are some questions in the chat, but forgive me, I need to move on because otherwise we won't have any time for the panel. So Mikko, if you'd be kind enough to actually cover those questions in the chat, I'd appreciate that. Thank you. Okay, then with no further ado, let us move on then to 6G Marcel. Your 5 minutes starts now. The floor is yours. Thank you.
Hello, good morning, good afternoon, everyone. I'm Christos Verikoukis from CBTC in Barcelona, Spain. Our vision is that we propose a new paradigm of elastic virtual infrastructures that can integrate in a transparent manner cell-free technologies for the radio part, networking management, and also security technologies in order to deliver end-to-end transfer processing and storage services. All this aided by advanced ML techniques. As you can see, the idea is to integrate cell-free with the 3GPP concept. We offer optical support to the cell-free technologies and high-level ML-aided management solutions. The idea of Marshall is to increase the capacity and spectral efficiency. We have two proof of concept experiments where we have outdoor events where users can stream photos and videos, and also indoor proof of concept where some 4K cameras can deliver videos to very dense spectators of the events. We also have a proof of concept related to cognitive assistance for next generation sightseeing, and we go the augmented reality idea one step further by considering real-time video or skin analytics and activity recognition in order to get personalized feedback for these sensitive, time-sensitive activities. The proposed solution can offer 20% energy reduction during light loads, especially when we have 50% OPEX reduction because of the fixed mobile converge, having two systems integrated in one. The proposed security solutions can decrease the security flows by 20% in the network. That's our vision. At the moment, we can explain a bit more during the second session.
That is great. Thank you very much. Very much appreciate you being concise and precise. Excellent. Then with no further ado, let us then move on to the next one. Forgive me that I'm not taking questions, but as I say, I want some time for the panel. So I wish to now move on, please, to Reindeer, the next one. The floor is yours. The time has started. Thank you.
Hello, I'm Lisbeth van der Perre from University of Leuven in Belgium, and it's my honor to be the technological lead for the Reindeer project. Now, the Reindeer project, as you can see at the bottom of this slide, focuses on resilient interactive applications through hyperdiversity in energy-efficient radio wave technology. And indeed, we start from the fact that we see that there are new applications that are dependable applications. They require that they can operate in real time and real space, but thereby merge both virtual and physical worlds, and that they should be reliable everywhere at every moment in time. And our vision is, in order to support that kind of applications, that there is a need for a new infrastructure, and the new infrastructure that is proposed is radio weaves. And as you can see on this cartoon, the radio weaves consist of panels where you would have a large number of antennas and also potentially intelligent surfaces, and that we connect them all together and operate them in a cell-free manner. And this infrastructure can both offer the physical air communication, but also computation to avoid that we need to go for long-distance connections wherever needed. So we want to bring everything close to the applications, both the intelligence and the access. And by doing that, we believe that we can really bring a new generation of networks that are ultra efficient in the usage of energy and bandwidth, and thereby can support the challenges that we are foreseeing here for future networks. An important element, as you can see on both graphs, is that we consider that positioning will be very important in future applications. Many applications only make sense if you know where they are, and we will therefore develop both communication and positioning in this kind of infrastructure, and also use the position information as a means for very reliable communication, because the position, we believe, will give you heads-on information on where things might start going wrong, and proactively make sure you have more resources in the cell-free infrastructure allocated to certain applications, and other resources if you know that they will enter a position where this might become more difficult. So I think this is very short in time, but I open the door for questions.
Super, thank you very much indeed. Then again, we will take questions offline, but thank you for a very interesting concept, which clearly has a lot of potential. Let us then move on to the next vision, please. Rise 6G, the floor is yours. Please continue.
Okay, so thanks for the floor. My name is Emilio Calvanesi Strinati. I work at CEVA-LT, and I'm the coordinator of the RISE-CG project and also the coordinator of 5G All-Star project in the Europe-Korean call. So the vision we have with the RISE-CG project is focused on the design and operation management of reconfigurable intelligent surfaces to create and shape on-demand smart grid environments where the wireless propagation conditions are co-engineered with a physical layer. For example, to this end, in the project, we want to dig into the potential of reconfigurable intelligent surfaces, which are two-dimensional, in some cases we can also say multi-dimensional surfaces of engineered materials, which has properties that are not static, but rather reconfigurable. So the idea is to explore innovative solution to extend the design of the antennas, which now go toward environments which is commonly considered as unconscionable and decided by nature. So what we want to do with the RISE-CG vision is to enable a wireless environment as a service. So by smarting users with using these reconfigurable intelligent surfaces and going beyond the current vision that the wireless communication environment is unconscionable and that the communication system has to adapt to it. With our vision, we want to see which are the potential of artificially controlling and shaping the wireless communication channel in order to support dynamics and dynamic adaptation of future stringent needs of beyond 5G CG service requirements, which might be in terms of electromagnetic field emissions, localization accuracy, can be energy efficiency, can be also frequency guarantees, as well also as adapting to changing in terms of legislation or regulations for specific population of users, for specific services, for a specific moment of the day, of the year, or either for a specific location, while imposing to incur with minimal connect and compute network redesign and configuration costs, which might be associated to the piloting of this smart environment. So with our vision, we propose a new concept of boosted areas, which are areas of wireless environment that we shape with a specific electromagnetic characteristic to naturally enhance a subset of intended performance for users of for a specific service or in a specific location areas, let's say following targets in terms of quality of experience of quality of service. For instance, we can selectively boost links in terms of capacity and or localization precision and or energy efficiency, or we can also push the boosted areas to lower the electromagnetic field exposure to intended or not intended users or a specific selection of the users, as well as improve the frequency in a specific location of the system. And actually another ambition we have is to participate to the CG race towards sustainability by actually lowering the energy waste we have in the system, considered end-to-end, as well as lowering the electromagnetic field exposure through the use of RS. That's actually the major vision we have. So if you have any questions, I'm glad to answer.
Okay, thank you very much for that. Again, there are some questions in the chat. Unfortunately, we need to move on. So if you'd be kind enough to take the chat questions and answer them directly, thank you very much for that. Then let us move on to the last presentation of this session, certainly not the least, and that is TerraFlow. The floor is yours. Please go ahead.
Thank you, Colin. I'm Ricard Vilauta, Senior Researcher at CBTC and the TerraFlow Project Coordinator. TerraFlow focuses on SDN. We propose to follow the quote. There's a lot of noise. If you can mute, that would be better. Thank you. We propose to follow the quote, don't try to do everything, do only one thing well. And that's what we are trying to follow in TerraFlow, focusing only on SDN. 6G will need capacity, gigabit speed, new spectrum, computing versus networking. For all of this, we need to provide more intelligence to our transport network. That's why we are proposing TerraFlow to create a new type of secure cloud-native SDN controller that will radically advance the state-of-the-art in beyond 5G networks. We need to autonomously deploy layer 3, layer 2 VPNs up to the edge to support these dynamic transport connections that also need to consider the underlying novel technologies, for example, in optics. With this new SDN controller, we shall be able to integrate better with the current NFV and MEC frameworks, as well as to provide novel features in flow management, service layer, optical microwave network equipment integration in the infrastructure layer, while incorporating also security using ML and forensic evidence for the multi-tenancy based distributed ledgers. So we have a clear motivation. SDN has been in the market for more than 10 years with great success, but operators have still not adopted the basic deployments. Telco cloud is slowly evolving, and we are not seeing a clear path of SDN introduction in the operators. With this, the 6G networks, massive SDN flows will be needed. Flow aggregation at the network core need to be more efficiently improved and to provide more dedicated services. And finally, also as a motivation, we need to be able to autonomously resist to attacks. That's why we have the objective of adopting SDN by the operators. We think that this is one of the major objectives. So we have accelerated innovations in the optical and IP domains. Then we need to also be able to handle a tera of flows. Teraflow comes from here, this clear objective. So for this, we need to have a cloud-native network operating system. We need to break down the silos and the SDN controller into multiple places, so we can be able to go to cloud scale. We think that that will help to get this teraflows objective. We need to easily integrate with distributed computing through the transport network slices. We need to secure the operator network. That means that we need to detect attacks, we have reactive protection, secure the network element configuration with DLT, support forensic evidence, for example, and have smart contracts-based verification and updates. So that's the main introduction to Teraflow, and I will try to answer the questions on the chat.
That's great. Thank you very much. So we are through the slideware. Well done, everyone. We are a little bit late, but not too bad considering. Let me stop sharing. So what I would now ask is that all the project representatives, those who can turn their camera on, we're now in the panel session. And what I would like to do is, if you wish to respond to a question, please either raise your hand in the video, if you have video. If you do not have video, please send me a message in the chat where you just put RH, raise hand, and then I will try and make sure we come to everyone. So what I'd like to start with is maybe an obvious question, but I would still like to hear an answer. Why do we need 6G? So, who would like to answer that? Well, that's a little bit distressing. No one seems keen to answer why we need 6G. Well, let's just give a bit of background first. I mean, it might sound an obvious question. Sorry, is someone raising their hand? I cannot see.
Yeah, at least
Nico, please go ahead. Yes, let's hear your voice, not mine. Please go ahead.
Yeah, so also very happy to hear your story, but so you wanted me to start. So certainly, kind of the world will not stop at 5G. So we definitely have heard here from Bernard Barani and from HexaX, from others, many things that we cannot do today, and that we recognize that would be good for mankind, good for us to be able to do. Yet also at the same time, there has been several have been mentioning the sustainability. So what the approach currently is, so certainly we are not on a good place with that. We are of course improving all the time, but yeah, that would be like a very short answer, and I can certainly expand that as needed.
Thank you, sir. Other thoughts?
Yeah, that's Emilio from RICG. Maybe it's some basic thing, but there is a moment where new technology comes to play, and those technology change the way a standard is defined. If you want to include that, let's consider, for example, the use of IRS, Requirement for Intelligence phases, that might be considered as a basic relay in the network, so it might be already included in the 5G standards, but might require very different way of controlling that, and that actually might require different standards. So the problem that new generation is linked to the thing that the current standard cannot exploit in a full way the potential of new technologies. Of course, there's also linked to business, but from the technology point of view, what we want to see here, at least in discussion from a point of view, is actually that current standard might be inefficient or might not definitely be able to cover in the right way the new technology we are developing now.
Thank you, sir. I see that, is it Zara from NEC?
Yes. Hello, can you hear me?
Yes, we can hear you. Please go ahead.
Yeah, so thank you for the time, and also good to see some of my colleagues here. Basically, the thing is that why 6G? The thing was that when you talk about generation, any G, there's always basically a big leap between the previous one and the next one. So of course, when we started with this big dream of 5G, and when we sat down to realize the 5G dream that we had, of course, we came up with some enabling technologies like NFV, like MEC, like SDN. So these were some of the enabling technologies. And as we became excited, we started, solving those, developing those technologies to cater to our 5G vision. So you see, with every solution comes with its own set of challenges, right? And very early on, when we realized that, okay, when we're virtualizing this whole networking domain, the problem that suddenly became very much evident was that basically it requires some very intelligent management, let's say, processes, which is not possible to intelligently be handled by human beings, especially when our requirement is to reduce the OPEX and the CAPEX as well. So I think with that point of view, it was realized that, okay, AI and machine learning is going to be like the next paradigm for the networks. But then I think it was not possible to let's say, completely tackle that in the framework of 5G, and considering that we are taking a big leap from our traditional management of networks towards now AI-inspired management. So that is why basically I would say this is the defining portion. So of course, because so a lot of voices were coming up about, oh, we can solve this problem, but we need some sort of an intelligent algorithms. So here it is. That's why basically AI, the 6G is going to be, let's say, highlighted by the AI and machine learning.
Thank you, sir. Any other responses from the panel?
I had raised my hand, but I cannot speak. I cannot show my camera.
Sorry, I did not see you raising your hand. Please go ahead.
Okay, so I think first of all, we had a vision on 5G for new kind of applications, and 5G is raising definitely performance on a number of aspects, but I think the true dependability and the reliability and the uniform good service is not going to be reached with the current 5G innovation. And a number of applications we see really requiring that will need new paradigms in 6G. I think further boosting the capacity to support an enormous number of simultaneous streams will require a cell-free approach. In the same sense, I think we will need much more distributed infrastructure if we want to offer uniform, really good services in many different places and for these new applications. So I think, although we do like the 5G progress, there is a number of things for the new applications that are not going to be supported well enough by 5G, specifically reliability, uniformity of service, and large numbers of simultaneous connections.
Thank you. Any other comments on this? Yes. Jaraf, have I pronounced that correctly? Jaraf, someone has just asked for the floor. Please make your comments about the need for 6G. Unfortunately,
yes.
Please go ahead.
Hello, everybody. Sorry. First of all, I'm not involved in any of the 6G projects. Just one comment about the need. Actually, we can ask the same question. We have some history about 5G and 4G. Why did we need 5G when we had 4G, and same for previous generations? So one of the things I would like to mention is actually a big part of the use cases mentioned in the projects will be addressed before 6G, will be added into the enhancement to 5G. I think in the few coming years, we will see a lot of artificial intelligence in 5G specifications. But the important thing is that any addition of integration of artificial intelligence, whether in the physical layer or the application or network or core, will be limited by the backward compatibility. So any improvement will need to guarantee that the existing 5G networks continue to operate correctly. So with the progress on these new technologies, at some moment, 5G will not be able to support the progress without while keeping a backward compatibility at the same time. So we will need to break this link between the progress on toward 6G and the existing 5G. So that's why we would definitely need a new generation starting from scratch and natively artificial intelligence based.
Okay, thank you for that comment. We're getting so many comments, I'm afraid I can't follow all of them, but maybe I can pick up on some of these questions, or at least put another question to the panel. And really that is this relation between 5G and 6G. So really I would like to combine a question. And the first one is, clearly, as was said, 5G is going to keep on evolving. Yeah. And 6G, we are starting the research, which we presented today, and I've certainly found it very impressive. At what point will there be a swap over in priority? At what point will 6G standardization take over from 5G evolution? When will that inflection point be? When will 6G actually be deployed? I think it is also a key point. So if you can consider those questions, when will the inflection happen, and when will 6G be deployed? So comments on those, please.
Colin, are you able to see the video from Mikko?
Please.
Yeah, so concerning the timing, so traditionally the time between these generations has been this roughly 10 years, and maybe recently has been going slightly down, but essentially something of this ballpark. And based on the view from HexaX, based on the view from all others, so that kind of is the expectation roughly also for the kind of moving to 6G. And of course, at this early stage, it also has not proven that there would be some like a bigger step from 5G to 6G. So that also remains to be seen how it will be. But at this stage of research, is good to be very ambitious and look at like some grand plans and visions as we are doing, and think that if we are more free from the current day approaches, so how would we build a new system? So that's what we are doing in this community, and that's great. And then if it would go the way how it has been before, so then somewhere halfway through the decade, so then the standardization activities would gradually ramp up, and then gradually move to be the stronger standard. But also it remains to be seen that whether this kind of revolutionary step will happen, or would it be more evolution.
Yeah, and I think that's a classic point. Is 6G an evolution or a revolution? Maybe we can add that to the overall question to the panel, because that is a key point. Other members of the panel who would like to comment on any of these points, the timeline or the evolution versus revolution? Forgive me, I'm struggling with 400 people to check who wishes to talk and who not.
Yeah, so maybe I can just stop. I raised my hand again. So I think, honestly, I think there might be some parts which are really a revolution. Like if we move to cell-free networks, we heard that in several of these proposals, this is a revolution. And it comes with a lot of unresolved challenges, as I will highlight later on. One thing I did not hear about in these things is, will we consider new waveforms? Because I think a new waveform could also somehow come technologically, at least, to some revolution. But I think the cell-free aspect and yeah, if we start working with so many different air interfaces and combine that with cell-free, I think that will be a revolution, much less a priori controlled compared to what we are still seeing in 5G and beyond 5G or 5G evolution. We see, of course, a bit intelligence and artificial intelligence coming in, but we don't give out the control yet. I think we still keep the control in hands, and I think that will be a revolution at a certain moment.
It sounds not. Okay, then let me try, and we're approaching coffee, which I think everyone who sat through this session, and indeed the presenters have certainly earned. But before we get to coffee, sir.
Roberto was trying to get in for a while from AI Edge.
Oh, forgive me, I didn't know that. Roberto, please go ahead.
Hi, yeah, I wanted to comment a bit on this transition, 5G to 6G. Try maybe to be a bit more provocative on this matter, if you allow me. I mean, in 6G, we did see this deployment of several new technologies, virtualization, software-defined networking, programmability, you name it. Some of them proved to be very complex to deploy. Some of them percolated into the real production network. ORAN now is emerging as a way to disaggregate the radio access network. This is more of 5G technology probably, but it's bringing in some AI into the machinery of the network. So going to the question of when there will be an inflection point, rather than giving a date, I would rather point out that if artificial intelligence is one of the key enabling technology for zero-touch management of 6G network, I think the turning point will be when AI and machine learning will be sort of tamed for managing network. With tamed, I mean that so far machine learning has evolved for video recognition, for natural language processing. The clear benefit in the networking domain are still to emerge. The clear challenges of, I don't know, poisoning attacks to machine learning of adversarial network are still to emerge in the networking domain. Possibly because the networking domain doesn't yet have a long tradition of data set on top of which build the challenges for machine learning. In video processing, in natural language processing, there are huge data sets on which researchers compete to show advantages. And this is something that is not that true in networking. This is a challenge we want to face in AI at the edge, because we want to also produce reference data set that the community can use to compare each other with other solutions. And also, in my opinion, it's very important to look at the AI that is going beyond the black box model, to look for an AI that is at least intelligible, that allows the human operator to understand why some solution has been taken. So the reply for me would be that the inflection point would be when such kind of goal will be reached. At that point, you can move from free research to standardization, because at some point, if you want to sell things, standardization has to happen. And you cannot do it anymore on 5G, because now 5G has been standardized, it's been deployed, it's been sold. So for 5G, that is too late.
Okay, thank you for that extensive answer. I think now we need to start wrapping up this session. I'd like to wrap this up by coming back to the actual name of the panel, which was Vision. And clearly, and perhaps unsurprisingly, we very much looked at technologies, but perhaps in the last couple of minutes, I could go around the project and ask them specifically, how is 6G going to change my or our life? So look forward to 2035. How has our life changed? I don't want technologies. I want to know how life has changed. So let's go in the same order. So maybe we can start with 6G brains. Maybe you could make a 15-second or 30-second comment. How will 6G change our lives palpably in what we do now?
So, for example, let's take, for example, the production line. The existing production normally we have deployed quite fixed in the Bosch, like a workshop. One production line you have to set up a fixed layout. This is for existing setup. However, in 6G configuration, when you deploy your production line, you need moving a lot of different machinery and also robots at real time. And this requires you reconfigure your network quite extensively and also intelligent. So that's automatically reconfigure your layout of your production line will be part of the 6G vision.
Agreed, but what thank you for that. What I'm looking for is what that means for me as an individual or us as a society.
So you can produce massive product in a short time period. Let's say reduce the production time for the
and customization, huh?
Yeah.
Exactly. Super, thank you, sir. Then let's move on to AI at the edge. Your 30 seconds starts now. Please go ahead.
Tough question. I think this should become a technology that enables to have an internet of humans. So something that can provide human with something that can be perceived in terms of a benefit. A greener network is something that can be perceived. A network that can support a new application, very holographic projection. It's a network that should be relevant for application and services that users are really looking for. So try to really look at what people want to do rather than pushing technologies on top of people.
Super, thank you, sir. 6G Demon?
Yeah, I agree that the question is tough.
I don't like easy questions. Keep going.
Well, I think that actually Bernard in his presentation already gave a very extensive list of the kind of application we can think 6G could enable, and those are pretty visionary already. So if we are at the point 10 years from now where those applications are actually a reality, I would be extremely satisfied. On top of this, let me add that what I would like to see is us running those applications in a super smooth and reliable and dependable way, which, you know, is not always the case. Not even nowadays with 4G or 5G, we can reach a point where we can fully trust the network. And I think that's a key point. So in 10 years from now, having those visionary applications plus the complete trustworthiness of the system, then that would be amazing, yes.
Super, thank you, sir. Forgive me, I need to make sure we have coffee because I need coffee. I don't know about anyone else. Dedicate 6G.
Yes, so as the previous speaker said, it's a tricky question. I think for me, it's really this human in the loop aspects. That's where I would see that, you know, a simple person's life can actually be changed, let's say, with applications that might be augmented reality, virtual reality, this really becoming true and helping in aspects of everyday life. And then, of course, all of the other aspects that the previous speakers mentioned as well need to come into play. Definitely security, greener networks, and what I was mentioning also in the Dedicat 6G presentation, really this inclusion of all people, connectivity for all.
Super, thank you very much. HexaX?
Yeah, more sustainable, inclusive, trustworthy society where, in addition to technology enabling the trustworthiness, so people also perceive that it is so, where humans can be in a richer interaction with each other and with the digital objects, and also the groups of machines and the entire infrastructures can be efficiently controlled and predictively maintained.
Thank you, Mikko. Marcel, sorry.
Marcel, having 0% perceived latency can ensure user experience and, of course, higher energy saving and security.
Lovely, short, sweet, like it. Reindeer?
Yeah, I think some of them have been mentioned for sure. Dependability, so not just a technology that helps, but that we can really rely on in all kinds of circumstances that can change our life. New applications have been mentioned. One thing I would like to add is interaction with devices that have no battery at all, meaning that we could interact with many more things that have an idea, that we don't need them to have a battery. That can be, of course, also something that results in a lot of e-waste, so we don't want to do that. So I think clean solutions for interacting with more and more things in our environment.
Thank you very much. Rise 6G? I'm not hearing anything, then...
Yes. Okay. So one point is to me to approach the sustainability challenge we have with the Horizon 2030, 2040, not only through the energy efficient management to the network, but for, as Mikko was saying as well, to what we can bring to ICT in general, to have more energy efficient production, end-to-end, more sustainability in general, use of the resources. The other thing is on the new types of service we're going to have. Like I think, for example, this immersive media experience where you're going to have holographic 5 sense interactive experience in communication. And I would say also the other thing is also that the network is changing from a connect network to a network where you have connect, compute, and control with the support of the AI.
Thank you, sir. And TerraFlow?
It has been said that the introduction of AI and neural networks, I think that it is important that this leads to a cost reduction, also for the operators, which also will result in the citizens themselves. This is very important to keep in mind that we need to keep reducing the cost while meeting the objective for greener society. Then this cheaper connectivity will result in broader connectivity that will bring us this Internet of Senses that we are expecting.
Super. Thank you very much, sir. Thank you to all the panelists. Thank you for everyone who's been watching this first half. We will now have a 10-minute break. We will come back at 1:45, 10 minutes break, so quick with your coffee. And then we've got a fascinating second section looking more at the technical enablers and the challenges to actually make the 6G vision, which we've just seen, a reality. Thank you very much for your time. We'll be returning in 10 minutes. Thank you.